Hello everyone. So let's talk about the linked list data structure today. Linked lists are basically a chain of nodes. So suppose this block that I have is one node and there can be many nodes. And when they're chained and linked together through a pointer, this is the pointer. They are known as a linked list. So each node can hold a value. Suppose they can hold a value of integers like 1, 2, 5, 6. This is a node holding a value, and then this is the pointer which points to the next node. So we usually call this pointer as next. And we usually get the value of the node using the val keyword. So these two are important keywords, next and val, in this series of nodes known as the linked list. So in the linked list, when you're searching for an item, you will basically start from the first node, which is usually called the head, and then move on and traverse through the linked list till you reach that item. So suppose you wanted to find an item with the value 5, you will traverse this linked list using the next pointer until you get this 5, and this traversal or searching an item will take O of n time. And if you want to add or delete a node, suppose you want to add a node at the end and you have a pointer to this pointer 6 and you want to add another node, so you can simply have a node pointing to 7 using the next keyword, and this will take O of 1. So adding, and even if you want to delete, suppose you have a pointer pointing to 5 and you want to delete 6, so you can simply, instead of pointing from 5, you will cancel this out. You don't need to basically cancel. What you'll do is you will make 5's next directly point to 7, basically point 5's next to 6's next, and then this part will come out of the linked list. So you will be remaining with 1, 2, 5 and 7. So O1 for delete as well. All right, let's talk about the code that we usually use for, like, basically we have a class as shown here, and what this basically represents is the value and the next. This is the constructor class that we create for every list node so that we can have a value assigned as 0 and the next assigned as none by default. This is what we use in functions usually. All right, moving on, let's talk about the traversal. So as I showed you in the previously, we traverse the linked list, and the code for traversal would be something like this. So we basically have a function traverse. We have a pointer head pointing to the first node, and until there is head, like until we do not reach the end of linked list, not because the end of the linked list would be none. So until we don't reach it, this loop will continue and we will keep on printing its value. So suppose we have 1, 2 and then none, so we'll print its value 1, and then we will point our head to the next of head. So now our head will come to 2, we'll print its value, and then our head will come to none, and this while loop will come out and our 1 and 2 will be printed. This is how we traverse. So it's very simple. Moving on, let's talk about append function. So as I already showed you, we can append at the end. We just need to know the node and the head. So we basically start from the head, we keep on increasing our head to the next pointer, to the next node, until we do not reach the none or the end of the linked list. And then we introduce like head.next equal to node. So suppose we have these two nodes, and then as soon as we reach here, okay, this should be while head.next. Yeah, so as soon as we reach here, as soon as we are at the last node, we can point it to a new node. This is how we append. This will also this function will take O of n time because we are traversing. We have not provided from the previous node, but if we were provided with the previous node, then it will take O of 1 time. But this one, because we are traversing, this will take O of n time. Moving on, let's talk about delete. So suppose you are given the head as well as the previous one that you want to delete from. So suppose you have a linked list, you want to delete this one, and this is your this is your head. So basically you will check if the node that you want to delete, it is there or not, and then you will see if that particular node is head, then you will simply make head equal to head.next. Basically you will make this as head and then return. This will be pretty simple. But in case that your head is not the node, you will simply make previous.next equal to node.next. So directly like this, and then return the head function. So if you know the previous and you know the head, this will take off one time as well, because you're not traversing anything here. All right, thank you for watching and see you in the next session.